Hello, here's a new tutorial for you. It's how to calculate the gram formula mass or the molar mass of a substance. We're going to be doing a lot of quantitative labs and you're going to need to know how much substance you have there, and this is the best way to do it. So we're going to find out what 1 mole of a substance is, and we're going to talk a little bit more about moles in class. We want to know the gram formula mass. How much would that weigh? So the first one is potassium permanganate, KMnO4. What we would do is we would look at each individual. This represents one formula unit of potassium permanganate, and we want to know how much it would weigh if we had a whole mole of these units. So potassium by itself weighs 39.10. So we have one potassium, 39.10. That would be the grams on the periodic table. That stands for 1 mole of that substance. Manganese weighs 54.94. And notice oxygen, there's 4 oxygens. So I take the 16 and I multiply it by 4. So I actually have 64 grams of oxygen. So they're all grams. So then just take your calculator and add them up. And that will give you the total mass of 1 mole of this compound. So it would be 158.04. That would be the amount of potassium permanganate in 1 mole of substance. So for every mole of substance, potassium permanganate, we would have 158.04 grams of that. So that's easy to measure out. So we don't actually work with a full mole of anything because that would just waste a lot of chemicals. But it is good to know how to calculate 1 mole, the mass of 1 mole, because we're going to use that as our conversion factor. All right, so now let's look at the second example, and that's ammonium phosphate. Ammonium phosphate actually has 3 nitrogens, and 4 times 3 is 12 hydrogens. Because remember, this 3 tells us that we have 1, 2, 3 ammoniums. So this 3 tells us we have 3 ammoniums, and then the phosphate. So I have 1, 2, 3 nitrogens, so I'm going to multiply this by 3. I have 12 hydrogens, so I'm going to multiply that by 12. I have 1 phosphorus, so it's just 1. I'm not going to do times 1. And then it's 4 oxygen. So oxygen, we already know, weighs 16. We multiply that by 4. So when we go to add this up, I'm going to start adding it up here. I see that I have 64 grams of oxygen. I have 14 times 3, which is 42 grams of the nitrogen. Then I have 1.01 times 12, 12.12 grams of the hydrogen, and 30.97 grams of the phosphorus. Go ahead and add it up and see if you come up with the same answer that I did. Great. I hope you came up with 149.09 grams. Now for some of you, you realize that we don't have that number of significant digits, so we would just write 149 grams. That would be per mole, per 1 mole. Okay. And that's how you calculate gram formula mass or molar mass of a compound. Now let's do one that's just a little harder. This next one is going to be hydrate. Here we see that we have zinc acetate, and it's got 2 water molecules attached. So it's a dihydrate. Zinc acetate dihydrate. And figure out the formula, the gram formula mass, we would have to include that water in there because it's in the crystal structure. So we have 1 zinc, which is 65.41. Carbon weighs 12.01, again off of the card. I have 2 times 2, so I actually have 4 carbons. So I'm going to multiply this one by 4. And then I have hydrogen, which is 1.01. And I'm going to multiply that by 6 because 3 times 2 is 6. And then I have 4 oxygen. So oxygen is 16 times 4. And then water, we're going to do water all together. And water weighs 18 because oxygen is 16 plus the 2 from the hydrogen is 18. So we have 2 water molecules. We're going to keep water together. So that's 36. So we're going to add the 36 to the 64. And then we're going to add it to the zinc. And then 4 times 12 is 48.024. And then 1 times 6 is 6.06. So those are the 5 that we're going to add together. Go ahead and work on it, and I will be with you in a minute. Very good. Now the last one. Oops, I forgot to give you your answer. Okay, you should have gotten 219.5. That's the gram formula mass of zinc acetate dihydrate. And our very last one is zinc phosphate, and this would be tetrahydrate. So we have a tetrahydrate there. So zinc, there's 3 zincs, so we would multiply zinc by 3. There are 2 phosphoruses. Each oxygen weighs 16, and there are 8 oxygen. And then we have 4 waters. So for the H2O, it would be 4 times 18. Again, I'm going to give you a minute to add it up. This time I am going to ask you to do significant digits. So our least significant is the 16 and the 18 because the other counting numbers are infinite. So we're going to have 2 significant digits. So see if you can get your answer to significant digits. All right, I think you should have gotten this, 458 grams per mole. Now, if we have 2 significant digits, we would write 460 grams per mole. But I don't like to lose any of my digits when I'm doing gram formula mass because I'm getting it off of the periodic table. So I like this number better. All right, well, I hope that helps you. And make sure you see me if you have any questions. Have a great day.